7.1 is systems of equations. And what we're going to do with 7.1 is we'll show you, there's actually three options you can do. We can do substitution, elimination, or graphing. And there's very little, well, really there's no graphing in this one, because graphing is the worst option. That graphing, you can get solutions, but depending on the solution, you sometimes you have to approximate because you can't tell exactly what it's going to do. So we're not even going to worry about graphing these. We're going to look at two possibilities of the easiest way to solve these without any graphing, and that's going to be substitution and elimination. But before we do that, let's kind of show you what a system looks like. When I'm talking about the systems, this is what we're going to have, is that the way we're going to look at it in 7.1 is we're going to have two equations with two variables. So that's what a system is going to look like. And the very first thing they're going to have you do, and kind of get in your mind what we're looking at. If we did graph these are two lines that you're going to have, and you're trying to figure out where these two lines, if you graphed them, had a line going this way, this one would probably look something like that. You're trying to figure out what this point of intersection would be. So you're looking for an ordered pair where the two lines would cross. But you're going to have three possibilities, because you could have it so that you've got two lines that intersect at one point. You could have two parallel lines where that there's no intersection. And then your third option could be that you're going to have the same line basically kind of written on top of itself. You'd have something like that, where this one you're going to have one solution, this one you're going to have no solutions, this one you would have infinitely many solutions, because there's all kinds of ordered pairs along that line that would make this thing work out. And that's what we're going to kind of look at, is finding out which of these three options it could be when we're going through this. This would be an infinite amount, yeah. Okay, now the very first thing they're going to have you do before they do any of this, before we go through and do all the solving parts on this one, is they're going to give you, basically in the beginning, is they're going to give you one ordered pair and they're going to say, does this point represent the solution to the system? And all they're doing at this point is they're saying, okay, here's the system we have, and they're just saying, is this point that we have here, is this point of intersection where these two lines would cross? You're going to say, yes it is, or no it's not. To find out what you're going to do for this one, all you have to do is to find out what the answer is going to be, yes or no, if it is or not. Just plug this ordered pair into both equations and see if it makes both of them true. Now here's the thing. Sometimes people will get one and then they'll be happy with it and go from there. But you've got to plug it into both equations. And it must be true in both equations. So to find the answer, plug the ordered pair into both equations and see if it makes both true. Okay, now here's sometimes, now if the answer to the first one is yes, if it makes the first equation true, then you have to go on to the second one and check it. If it makes the first one no, if it's false, you don't have to check the second one, because it has to be that both answers have to be true. So if you take this equation, this solution that they've given you, and plug it in here, and it makes this equation not be equal, you don't have to worry about plugging in the second, because they both have to be true for that one to be the case. Okay, so what we'll do is, let's just say, just out beside this, we'll call this equation 1 and equation 2, just so we can kind of separate which one it is here. Let's take 2, 3 and plug it into x plus 3y equals 11. Okay, so take these two values we have here and plug them in for x and y. So if we do that, you get 2 and 3 here. And really the question you're asking here is, okay, if I plug those numbers in, does it actually equal 11? Well, that's 2 plus 9, that does equal 11, right? Okay, so far, so good. Made the first equation true, then now we're going to the second part. So now we're going to take 2, 3 and plug it into x minus 5y equals negative 13. Again, really when you plug those numbers in, that's the question mark. Does that equal negative 13? So that's 2 minus 15 equals negative 13. Yes, it does. So as long as they're both yes, so they ask you, is this a solution to the system? Then yes, it is. They may ask it if it's, just state if it's a solution or not a solution. So in this case, we'll say yes, it's a solution. Okay, so that was a yes one. Let's give you one that's a no, just so you can see for sure. Okay, so this one will go 2x plus 3y equals 17. And then x plus 4y equals 16. And the ordered pair is going to be 2, 5. Okay, and again, we'll call this equation 1 and equation 2. This will go here. Alright, so taking equation 1, we're going to take 2, 5 and plug it into 2x plus 3y equals 17. Okay, and for this one, you can kind of see right off the bat that 4 plus 15 does not equal 17. So, and again, as soon as one of them is a no, you don't have to go any further. Just stop right there. Is that a solution? No, if it doesn't make this one true, there's no way it can make both of them true. That's as far as you got to go. So, as soon as you get a no, you're done. If you get a yes, just keep going. They'll do the same thing in section 2. The only difference is we're going to have 3 equations. And it'll be the same way. That you plug it into the first equation. If it's true, go to the second one. If it's true, you go to the third one. If all 3 are true, then it's true. As soon as you hit a no along any one of the steps, then you stop and you're done. And you say, no, it doesn't make one equation true. There's no way it can make the whole system true. Okay, so that's the first thing they're going to do. Here's a system, here's a solution, or possible solution. Is this an actual solution to it? And again, just say yes or no. Okay, so here's where we actually start solving and going through and doing everything. You've got two different ways you can do these. The first one we're going to look at is the substitution method. And this is probably, of the two options, this is the one that usually people like the least because it's got, depending on the problem, sometimes it makes you do more work than you really have to. But we'll show you this one anyway and kind of go with it. With the substitution method, here's the first thing you're going to do. We'll kind of show you the steps for it here. It may be a little bit different than the way the book says it, but this is kind of the way I always kind of look at it. Step one, you're going to get one of the variables in either equation, doesn't matter which one it is, by itself. One variable in either equation. I guess the technical math term there would be that you solve one equation for x or you solve one equations for y. Isolate it for, we get y equals something and you get x equals something. Okay, once you do this, you get y equals 2x minus 3 or you get x equals 4y plus 12 or whatever the equation is. Second thing you're going to do is that if this came out of equation 1, then you'll take this, whatever you get for the equation from equation 1, and this is where the substitution part comes in. You're going to substitute the equation from step 1. And the best way we can say it here is we're going to say we're going to substitute it into the unused equation. Because right now we only have two equations, so we've used one and the other one we haven't done anything to it. Oh, let me add one more thing to this one. After you substitute this equation into the unused equation, you basically now you've got this equation you can actually solve because it's going to have one variable. Just solve that equation. I'm going to go ahead and make this the third step here. So we'll just say solve the equation for the variable that is there. Because once you've done step 2, you should either have all x's in the equation or you got to have all y's, one of the two, because you've done the substitution and replacing. So now you've got something you can solve and actually get x equals 3, or you can get y equals 4, or whatever the number is going to be. And once you've done this, now you've got one variable. The last thing you'll do is you'll take the answer from step 3, x equals 2, y equals -5, whatever that number is. And you're going to plug that number back into either one of the original equations to find the other variable. Now, here's one where you can actually take a little bit of a shortcut to make the answer a little bit easier. If you take this answer you've gotten in step 3, x equals 2 or y equals 5 or whatever the answer is, if you'll plug that one actually back into the variable equation that you have in step 1, you'll get the answer for the other variable in the least amount of work and the fastest way you can get there. So let's just say that we'll use the answer from step 3 to plug into any equation. And we'll just say in parentheses, preferably the equation in step 1. And again, you don't have to use the one in step 1, but if you're looking for the fastest, quickest way to get the answer, that's going to be the equation you want to use, because you've already got it set up to make it easier for that part. So use the answer from step 3 to plug in any equation. To find the value of the other variable. Okay, now, and the biggest thing on this one is, and it's easy when you're going through the homework because a lot of people will get excited because they'll get one answer, they'll get x equals 5. They're like, all right, I'm done. They'll plug it in, and then the homework can say, well, you've got one answer, don't forget the second one. And on the test, sometimes people get excited because they'll get one of the answers, and they'll get, y equals 4, and like, hey, I'm good, I got an answer. And then they'll forget to go back and get the x value because, again, you're looking for an ordered pair answer. So I guess the last thing, it's really kind of a cleanup thing here. Write your answer in ordered pair form. Well, let's say write your answer as an ordered pair. Now, and depending on the homework, they might let you just put in each individual answer as you get to it. They may have a block for x and y equals. But most of the time, if you're doing these, actually working stuff out, you'll put in an ordered pair form. Okay, so there's, again, 4 steps, not too bad. Now, here's the thing with this one. Here's where sometimes they'll tell you, you can use they'll have you some where they tell you, all right, do this one with substitution, then we'll do some in a minute where we're going to do some with elimination, and then you get to the last ones and they say, okay, solve this ever how you want to, we don't care, just find the answer. Substitution is one of those that if you have the answer, if step 1 is done for you in the equation when it's set up, then you want to do substitution because they've already done the big part of step 1 to get the work done there. If step 1 is not given, it's probably going to be faster to do elimination method because of just how it's set up and the work you're going to have to do. So substitution method, I would say this is the one you want to do when you're given step 1. If they don't give you step 1, most people prefer to do elimination method, which we'll show you that one here in a little bit. But okay, so here's an example. Let's run through a couple of these and make sure we got it. So for this one, we'll go x plus 3y equals 8, and then y equals 2x minus 9. And we'll do this one where it's already set up in, basically where step 1 is done for us. It makes it go a little bit faster as we're running through this thing. Okay, and then they don't label these, but just so we can kind of make it a little bit easier to talk about it, we're going to go top and bottom. Let's just say we're going to label this as equation 1 and equation 2. Here's where, again, if they've got step 1 done for you, it speeds this process up because in this one, step 1 is already done. And if step 1 is done for you, then definitely go ahead and do substitution. If it's not, then, again, we'll show you what I would do. Okay, so step 1 is done for us. Step 2 said we're going to take this equation and plug it back into equation 1. And again, when you've got this one, where you've got y equals 2x minus 9, remember that you're going to replace y with 2x minus 9. And that's going to be in equation, well, this came out of equation 2, we've got to plug that into equation 1. Okay, so we had x plus 3y equals 8 for equation 1. And we're going to take out this y and replace it with 2x minus 9. Okay, so the x will go here, 3 goes there, and equals 8 goes there. Okay, so right off the bat, once you've taken this y out and replaced it with 2x minus 9, you've got to do distributive property. And if you want to go ahead and put a 1 in front of the x there, you can, just to kind of, make it easier as you go through this. You've got 3 times 2 for 6x. You've got 3 times negative 9 for a negative 27 equals 8. So there's 7x minus 27 equals 8. Let's add the 27 to both sides to get the x by itself. Got it here, divide the 35 by 7, so then we get x is equal to 5. Okay. And again, the good thing about the homework is it's either going to ask you to put the answers in order pair, it's going to give you a block for x and y, that once you've got the x value, you've got to go back and figure out what the y value is, because you're looking for where these two lines are going to cross. So once we're here, we're going to take this x equals 5, and we got to plug it back in to find out what the y value is going to be. Okay, now, and you can plug it into any equation that's got x and y in it, but the one we use back up here in step 1 is going to be the best one. So we said right here, this was already done for us, so we're going to use y equals 2x minus 9. So we're going to take out this x and put 5 in its place. And the good thing about using that equation is that it's already got the y separated out. And once you plug it in here, you're just going to do some adding, subtracting, a little bit of multiplying. 2 times 5 is 10. Minus 9, the y is 1. So final answer is an ordered pair. It'll be 5, 1. Okay. And the two system, the two ways we'll look at being able to solve the substitution elimination. This one, you do all the work on the front end, getting everything out to get this first answer. And this one is set up so once you get the first answer, the second answer comes really fast. When we do the other way, the first answer comes quick, and then it takes a little bit longer to get the second answer. So they're kind of opposite of how they go. But again, most people prefer doing the elimination or the addition method. Substitution, most people just don't like it just because you've got to rearrange it and work some stuff around. But anyway. Okay, so that's one where you have the equation set up and everything's good. They got step 1 done for you. Let's give you one where they don't have step 1 done for you. Actually, let's give you one that's got a little bit of a twist to it. Let's go with x equals 4y minus 2. And x equals 6y plus 8. Yeah. Now here's the catch on this one. And sometimes they give you a problem that it's almost easier, and then sometimes people make it a little bit tougher. Both of these are already set, so this is x equals and this one's x equals. Since they're both x equals, then if x is this and x is also this, these two things have to be the same. So then just do 4y minus 2 equals 6y plus 8. Because they kind of already did both step 1s for you. So if you take, this is, if you say replace x with this, you're just going to take this and plug it down here for this part. So that's one where sometimes they get a little bit sneaky, and sometimes it throws people off because they almost make it easier, because once you do the substitution, you don't have to do distributive property and all this other stuff that's here. So since they're both x equals and x equals, then just take what the x equals here and set both of those equations or expressions equal to each other. Okay, so from here, you're getting the y's to one side and x to the other. Doesn't matter really which way you put it. I'm going to subtract 4 from both sides. So we've got negative 2 is equal to 2y plus 8. Subtract the 8. So we've got negative 10 is equal to 2y, and divide those two numbers. So we get that y would equal negative 5. Alright, again with that one, you're only halfway there. You've got to take this negative 5, and you've got to plug it in to find x. Now the good news is both of these already had x equals, so really you could use either equation back up here. And it doesn't matter, it's just whichever one you think looks the best to you. I don't know, we'll just go with the first one, I guess. We had 4y minus 2. So the y was negative 5. So x would be negative 22 when we work it out there. Okay, again, if you put that as an ordered pair, negative 22 and negative 5. Okay, so that was one where, again, it was a little bit tricky because it wasn't just one equation that was solved for x, it was both. And if you get that, it's actually a good part because it makes going through the work a little bit faster than even the first one we did back up there a minute ago. So, again, just show you that one because sometimes it's a little sneaky. It's always good to see those. Alright, here's what we'll do. After this one, I'm going to go ahead and show you one that's set up where step 1's not done for you. Because, again, if they don't, because y'all are working these out, nobody's ever going to see how you're going to do this. And even if, it's good to know both because sometimes equations that you do, I think it's in 7.4, that there's sometimes where a problem is set up when it gets a little bit more complex that if you can do elimination, it makes the problem a whole lot easier. And sometimes if you do substitution, it makes the problem a whole lot easier. It just depends on how the problem is set up. So let's show you how to do the elimination or the addition method. Technically, it's the addition method. Sometimes people call it the elimination method because what you're going to do is you're going to eliminate one of the variables so that you're down to where you only have one variable. So it's kind of set up this way. Now, here's the biggest difference with substitution and the addition method. With the addition method, you're going to basically, you want it so that you have all the variables lined up. You want the variables lined up, you want the x's lined up, you want the y's lined up, you want the equation symbols lined up, and then you want the constants lined up. So that's the biggest difference when it comes down to these two. And when we're saying lined up on these, we want them stacked on top of each other, basically, is what we want. So you want the x's on top of each other, you want the y's on top of each other, you want the equal signs on top of each other, and then you're going to have the constants. They all need to be stacked on top of each other, so everything is lined up. It's got to be set up. When you're doing elimination method, you actually want it different, where you've got one where you've got the y by itself, and then the other one you've got x's and y's and all kinds of stuff together. So that's really kind of the biggest difference of the two of these. Okay, so that's kind of your first bullet that you're looking at. The second bullet, here's the big thing you want to have. You want it so that once you've got everything lined up, you want one variable. Doesn't matter if it's x or y. Doesn't matter which one it is. Either way is fine. But you want one variable with the same constant where one is positive, not constant, sorry, you want the same coefficient. Sorry, I had the constants on my mind last minute. You want one variable with the same coefficient. Where one is positive and the other is negative. Because if you can do that, then when you do the addition method where you're just going to add them together, you're going to have 4x and a negative 4x. Well, if you do 4 minus 4, it makes it 0, which means now that variable is gone and the equation just has the y value that's left in it. So that's the whole big thing you're trying to do with the elimination method is you got to have everything lined up first. Once you got it lined up, you want 4x and negative 4x, or you want 5y and negative 5y, and then just add the two equations together. And once you've added the two equations together, you just solve the remaining variables that's left over. So this one, I guess if you put those in steps, that's steps 1, 2, and 3. And it's not really steps because we're going to put a little hint back in here with one of these. This is where it gets the same as the substitution method, because once you've got this part done, this is kind of like step 3. Well, once you get the first variable, then you're going to take that value, plug it back into either one of the equations you had in the beginning to find the second value of the other variable that you're working for. Okay, so and again, it's kind of steps, but there's some, you can kind of tweak these around a bit. If you want to call those steps, you can call them steps, where it's steps 1, 2, 3, and 4. And then we'll say that there's a hint that you can kind of do with this one. And we'll kind of look at it, and we'll take it one step at a time. We'll do one where everything's nice and lined up, and we're good to go. And then we'll look at one where it's close, and then we'll give you a hint of one thing you can do with it. All right, so let's throw out a couple examples to you here. let's go with x plus y equals 1. And then x minus y equals 3. Okay, now let me give you a heads up. Here's where most people are going to miss this one. They're going to miss it for the easiest things in the world, because they're going to look at this and go, oh, here's the y and the y. If I do addition method, I can just put this together. That drops out. That'll go to 0, which means this thing is 0y, which means that y is gone. And they'll say, all right, I've got x's here, so then I'll do x equals 4. But why is that wrong? Because you've got 2x, right? Really, it's 1x plus 1x. And sometimes people just get excited and get in a hurry, and I think they'll just try to do it too fast. So when you're doing these, I would say anytime you have a problem that just has an x or y, I'd go back just to be on the safe side. Go back and put a 1 in front of it. Because I've seen too many people miss these problems because they see the x and they go, oh, there's just x, and then they'll add the number over here. And everything else they do in the problem is correct, but then they're off by that one problem in the beginning. So make sure you get 2x equals 4. And you get x equals 2. Alright, so from this one, once you got the x equals 2, here's the fast part of this one. You get this first answer really quick. The longer part of the answer is taking this x equals 2 and plugging it back into either one of the two equations to find out the y value. It's going to take a little bit longer, but again, this is one where the front end of the answer goes a little bit quicker than the second answer here. So we're going to plug it in to find x. Sorry, we've got x, we've got to find y. And it doesn't matter which one you pick here, just whichever one you think would be easiest. If you want to go with the second one, we've got x. Let's go with the first one. X plus y equals 1. I'll take out the x, plug it in for 2. Subtract 2 from both sides. So y is negative 1. Okay, so as an ordered pair, you would have 2, negative 1. Okay, so that one not too bad because you had the numbers, everything was perfect, and it was all good here. Alright, now let's show you one where everything's not exactly how we want it, and then we'll kind of step it up and go from there. Okay, so for this one, 2x minus 7y equals 2. On the bottom, we've got 3x plus y equals negative 20. Okay, so this one, we don't have the numbers that we need. We've got, before, basically, going back to the previous problem, we had a positive 1 and a negative 1. We were good there. This one, we've got a 2 and a 3. We've got a negative 7 and basically, and again, just go back and be on the safe side. We've got a positive 1. So here's what you have to do. Here's where you can kind of add in one of these. If the numbers don't exactly match up, let's just say it this way. If the coefficients may not be a technical term, but we'll say it this way. If the coefficients don't match up, we'll just say it that way. You can multiply 1 or both equations. Sorry. Yeah, you can multiply 1 or both equations. By any, now you can't use 0 because that messes everything up. So we'll say any non-zero number. to help it out. Okay, so here's what we're looking at. You've got a negative 7 here. We need a positive 7 here for this one. So what we can do is we can take equation 2. Let's take equation 2 and multiply it by 7. And if we do that, that'll make this 7y, and we'll have the negative 7y, and we'll be good to go. So we're going to multiply equation 2 by 7. Okay, so first equation is good. We had 2x plus 7y. Oh, sorry, minus 7y. Equals 2. Taking equation 2 and multiplying it by 7. Now, when you multiply it by 7, make sure you multiply everything. So it's the 3 times 7, it's the 1 times 7, it's also the negative 20 times 7. If we take equation 2, multiply it by 7, that's going to be a negative. It's going to be 21x. We have a plus 7y. And then negative 20 times 7 would be a negative 140. And again, the whole reason we're doing that is that we want it so that either one of the variables, either x or y, have the same thing. Yeah. So, and again, once we do this, now it's easy because if you do 7 minus 7, this goes to 0, which means this variable is out. Put these two together, that's 23x. 2 minus 140 would be a negative 138. And then we'll take the 138 divided by 23. So x would be negative 6. We go back up here just real quick. We took this equation, and we took this entire equation and multiplied it by 7. Right here? Oh, okay, because it's basically 7 times 3 for 21 for the x. It's 7 times. We're not doing equation 1, just equation 2. So this one we're just doing 7 times 1, and that's what we're getting. And here's basically what you're doing is when you're going through these problems, you want, obviously if you've got one here that's just got a y or an x, that's going to be easy to pick from. But the other ones, these numbers, you're looking for numbers that are multiples of each other. Like if this was 2 and 4, it would be easy. Or if this was 5 and 10, you can multiply by 1 by, 2 or 3 or something like that. Okay, and once you get to here, you get to negative 6, you've got to take this thing and plug it back in to find y. And again, you can pick any one of the equations to find y. You can go back to either one of these two. You can go back up here to the beginning to get this equation. It's just whichever one you think would be the easiest one to plug it back into. Has anybody got one that they think would be the easiest one to get there? It really doesn't matter. Top one, so 2x minus 7y equals 2. Okay, so we're going to plug in negative 6 for x, and then just work it out. So it's negative 12 minus 7y equals 2. Add 12 to both sides. So negative 7y would equal 14, so then y would equal negative 2. Alright, so we plugged in negative 6 for x, and y was at negative 2. Okay, and again, this one's kind of the opposite of the other one, that most of the time getting that first value goes pretty quick. It's the second number sometimes that takes just a little bit longer because of how the problem is set up. But even then, it's not too bad. It's still, here's where most people like doing the elimination or the addition method, because you don't have to do distributive property, where when you do substitution, a lot of times you're having to do distributive property, and you've got to, it's a little bit more involved than going through with the elimination method or the addition method. Okay, so there's some where you may just have to multiply it by, so the first one we had, you don't have to do anything, just combine the like terms. This one we had to multiply one of the equations by 7. Let me show you one more here real quick before we get to them. There's two more I want to look at, but let me get you one more. Go x plus 2y is equal to 2. Go with 4x minus 3y equals negative 25. And again, it's kind of simple, but I'd go back and put a 1 in front of that x that's there, just so we know we got a marker. Okay, really similar to the last one. We've got the 1 and the 4, so we could take equation 1 and multiply it by 4. Now, when you do that, though, this one is already a positive 4 on the bottom, right? Equation 2. So if this one is already a positive 4, we want this one to be a negative 4. So when you multiply equation 1, I'd say multiply it by a negative 4, because this one's already marked as a positive. If this one's positive and this one's positive, whichever one you multiply, if they're the same signs, then when you multiply, go ahead and multiply by a negative so that you'll change one of the signs so that you'll have one positive and one negative. So that's just one little thing you can do, because sometimes people will get there and they'll have, this is 4x, and then they'll have this equation, and then they'll look at it and they'll go, well, I've got 4x and 4x, what do I do? Well, now you got to go back and multiply one of them by negative 1. So, if you kind of see that as you're working through it, you can go ahead and multiply by it here, so you can change it and just, basically combine two steps into one. Okay, so that's a negative 8y, and that would make that one a negative 8. Bottom equation, we'll keep it the same. It's 4x minus 3y equals negative 25. Okay, so now that you've got the positive and the negative, just start adding and subtracting here. That'll go to 0, which is what we want, so that's gone. Negative 8, negative 3 is a negative 11. Put those two together, make it a negative 33. Divide those two numbers to get y equals 3. Okay, and then same thing, you've got the y value, you've got to plug in, find x. And again, you can pick any one of the equations you want. You can go, now we didn't change this one, so you can go here, you can go with that one. It might even be shorter here with this one just to do x plus 2y equals 2, because it just looks like it's a little bit smaller numbers. Okay, so the y is 3. So that's x plus 6 equals 2. Subtract 6 from both sides. So we got x equals negative 4. Okay, so again, if you look up and you see numbers that you can take one equation, multiply it by 2 or 3, in this case it's 4, negative 4, just make it so you've got the same numbers where you've got one positive and one negative, and that makes the part of it the easiest way to kind of get through those. Now, here's the toughest one of these that you have to do. So we'll go with 3x minus 4y equals 11. 2x plus 3y equals negative 4. here's what makes this the toughest one when you go through this one. Is now if you go from the smaller number to the bigger number, is there a whole number you can multiply by 2 to get to 3? I mean, you can do 1.5, 1.5, right? But then you run the chance of running through some decimal, because if you do that, 1.5, now you got 4.5. Now you're running into decimals. If you go from 3 to 4, same thing. There's nothing you can multiply to get from 3 to 4. So these aren't multiples of each other. You know, if this was a 2, it'd be easy. You can multiply this equation by 2, and you have 4 and 4. But if you go through these numbers, if you go from the small number to the bigger number, and they're not multiples of each other, then what you're going to have to do is you're going to have to multiply both of those. Or both equations. And now here's the easy way to kind of do this. You can either, because if you have 3 and 2, what's the first number 3 and 2 would have in common? It'd be 6, right? So basically they both would have to be 6. Or you could go with 3 and 4 and say it would be 12. You just got to multiply, and when it comes down to that, you're basically going to switch where these two numbers are. You put the 3, multiply equation 2 by 3, take this 2 and put it here, and multiply equation 1 by 2. That way you get 6x and 6x. Well, yeah. Now, you also could, and here's what I would tell people. You know, if you want to get stuck on the x's, you can. But just going back and going through these and grading tons of papers and seeing where people make mistakes. If you already have one that's positive and negative, I would go with that one. Because if you go back and multiply if you multiply this one by -2 to make that -6, and left this one as a 3 to make it +6, sometimes, again, just grading papers and watching these, if you multiply by a negative, somebody almost always will miss a negative sign through here somewhere and throw their answer off a little bit. If I'm grading through these, somebody's guaranteed to do it. So I would say best thing to do is take the numbers that's already positive and negative, where you've got the -4 and the +3, and switch these two numbers. So I would say put the 3 up here, take that 4, and put it down here. And that way you get -12 and +12. You don't have to change any signs, which makes it a lot easier because you don't change signs. And that's usually where sometimes people get a little bit off, is that if you change signs, sometimes they'll change 1 or 2, but maybe not 3, and then they miss one along the way. Okay, so we're going to take this entire equation, multiply it by 3. Take this entire equation, multiply it by 4. So if we do that, we get 9x minus 12y equals 33. On the bottom, multiplying by 4, you're going to get 8x plus 12y equals -16. Now, again, you can do whatever you want to do. And sometimes they make it where that they're both the same signs, and you have to multiply one of them by a negative just to make it so you get one positive, one negative. But just from all the papers I've graded, people make fewer mistakes if you don't have to change signs. So if they already have the signs positive and -40, go ahead and use that one, because it's one less thing you've got to worry about as you're working through this problem. Okay, everything's lined up. We're good to go. 17x, that goes away. Equals 17. There you go. So your x value is 1. And once you get that value, we're going to plug it back in to find the y. And again, you've got any one of these 4 equations you can pick from. I would say stick to the smaller numbers because this is your original back here. You can go with these down here if you want to. It'll still work. Just the numbers will be bigger. Let's go with equation 2. We haven't plugged anything in equation 2, so let's go with that. Alright, so plugging in the 1. We got 2 times 1 plus 3y equals 4. So 2 plus 3y equals -4. Subtract 2 from both sides. So y would equal -2. Okay, so, and that's about as bad as they'll get, where you have to multiply both equations. And again, even then it's not too bad, as long as you just take your time, don't get in too big a hurry. You may get an occasional decimal answer. If you do, don't worry about it too much. Go ahead and go through the problem and check it and see. Now, if you get something really weird, you might want to check it, because sometimes if you just kind of going through these, sometimes the biggest mistakes people will make when they multiply these equations is they'll multiply the values of x's and y's. They'll forget to sometimes multiply the constants. So, if you get something weird, if you get here and you get 17x equals like 20, you might want to just go back and real quick check and make sure you multiplied your constants by those numbers to make sure everything matched up. Most everything should be whole numbers, but again, occasionally you'll get a fraction as you're going through this. Okay, here's what we haven't done yet. We haven't done anything with the no solutions and the infinitely many solutions. So what we'll do is we'll say, all right, here's some problems. You can solve these ever how you want to. Elimination, substitution, the addition method, whichever way you want. And just tell what the answer is. Now, these will be the trick questions so that when we start solving these, you'll get to the end, you'll see it, and it'll pop up in a hurry that you'll do something, you'll go, wait a minute, what's wrong here? Because you'll see it real quick when we go through these. Okay, so we'll go with y equals 3x minus 5, and then 21x minus 35 equals 7y. Okay, now, again, this one you can do elimination method, you can do the addition method. But if they already have it so that you have y equals, they've done step 1 for you, substitution might be a little bit quicker with this one. So let's take this equation, let's plug it into, again, if we go back and put equation 1, equation 2 here. So let's take equation 1 and plug it into equation 2. And again, when you do that, you're going to replace y with 3x minus 5. And sometimes it helps, I know it's a math class, but sometimes if you actually use the English words and write it out sometimes, that you're going to replace y with, and kind of take those out, it makes it easier to kind of see exactly what you're doing. So I've had people before that they get lost in the substitution. So we're going to take out the y and replace it with 3x minus 5. Okay, so 21x minus 35. On the right-hand side, we get 21x minus 35. Okay, so if we start moving the x's to one side, and hopefully right there you go, wait a minute, something looks a little funny. Go ahead and start moving them one side to the other. Take the 21x and move it so it's on the same side. If you do that, you get 0x here, which means that's a 0. You also get 0x here, which means that's also a 0. So you get negative 35 equals negative 35. No variables left over, right? We've tried to solve for x, and x is gone. So as soon as and then here's the trick question part. Here's where you're going to know if you're going to have no solution or infinitely many. When the variables disappear, it's a trick question. So then the answer is, okay, does negative 35 equal negative 35? Is it always true, or is that never true? Always true, right? It's the same number on both sides. So since this is always true, that means it's the same line on top of itself. So this would be an answer that would be infinitely many. Okay. And the only difference between the infinitely many solutions or the no solution is that if you were doing no solution, if we just go back over here real quick, let's just give you a dash line over here. Let's say we had solved this thing, we got all the way down to here. Let's say here's our what if here. What if we had solved this thing out and we had like 10 equals 35? Does 10 equal 35? Never, right? Well, unless you work for the government, then, you fudge the numbers and make it work out. But in the real world, 10 doesn't equal 35. If that's never true, then that means you would have no solution. So the infinitely many and the no solutions, they're almost the same in that the variables go away, all the variables are gone, and you're left with two numbers. And if the two numbers are the same, it's always true. If the two numbers are different, it's never true. It's no solution. And that's the only difference of the two trick questions, when it comes down to it there. All right. If you have the infinitely many solutions, or we'll say IMS for short, one thing they're going to ask you to do is they're going to say, all right, well, we've got this thing of infinitely many solutions that we're going to pick from. They want you to use an equation so that you can actually take some values and plug it back in and find it. So what we're going to do back here is take the equation where you have y equals 3x minus 5 if we've done substitution, and basically just pick this equation and say, okay, our answer is infinitely many solutions. We're going to have that. The equation you could use, we're just going to basically say we're going to write an equation. And you can pick either one of the two equations. They really should, they always pick the one that's like the easiest way to look for it here. So back up here, we have y equals 3x minus 5. Basically just pick the easiest one. So they should say, give you an option of no solution, infinitely many. And then the next thing they should give you is if it's infinitely many, they'll say write an equation to represent the the numbers you can plug into this thing. Basically just go back and pick one of these two equations back here, and it's okay. You can take this equation and plug it in and write it there, and it's fine. Last thing here is a couple of word problem. Really, we're just going to do one word problem. Really short, really easy. This is not, one train leaves Albuquerque at 7 o'clock going 45 miles an hour. The other train leaves San Antonio, 2 hours later traveling 85 miles an hour. This is really easy kind of problem here. Okay, the sum of two numbers is 7. I'm going to cheat just a little bit. We want to write these in two different colors so we can see the two different equations. If one number is subtracted from the other number, the difference is minus 1 or negative 1. Find the numbers. Okay, so they should basically give you two sentences and then tell you to find the numbers. The first sentence is one equation, the second sentence is another equation, and that'll be the two equations that you're going to use to write out the system for what you're going to need to do here. Okay, so if we do that, first equation, wrote it out in blue. The sum of two numbers is 7. That's x plus y equals 7. If we look at the red part, if one number is subtracted from the other, doesn't matter if you do x minus y or y minus x. They don't get specific about which one is which here. They just say find the two numbers, and the order doesn't matter. If the answer is 2 and 3, you can also put 3 and 2. As long as you find the numbers, the order that they're in, it does not matter for these. So if you do x minus y, that's going to equal negative 1. And again, you could do y minus x because they didn't say specifically that one had to be first and one had to be second. Just, you subtract the numbers, you're going to get negative 1. Okay, once you do that, there's your system. Solve it by substitution, elimination, whatever you want to do. And again, just so you don't miss out on anything, I'd go back and put 1s in front of these. And you've already got 1 minus 1, so let's just take this thing and put it together. Let's do the addition method. 1x plus 1x is 2x. That's 1 minus 1, so that's gone. 7 minus 1 is 6. Divide those two, and you get x equals 3. Right, and same thing as before. You've got to plug this thing in. Let's go with it. I like addition better. Fewer negatives. Let's go with that one. So you got x plus y equals 7. Take the 3 and plug it in. So 3 plus what is 7? So y is 4. Okay, now that one we specifically solved for that one as x was 3 and y is 4. You can, as long they're going to say just list the numbers, so you can put 3, 4. You don't have to put an x and a y with these. As long as you've got the answers 3 and 4, it doesn't matter if you put the 4 first or the 3 first. Just tell me the two numbers, and we're good to go. All right, so here's the tougher word problem. Okay, this one has 3 parts to it. They're going to ask you to write a cost function. They're going to ask you to write a revenue function. And then they're going to tell you to determine the break-even point. Okay, so there's our big word problem. That they're going to ask you to do 3 things. Write a cost function, write the revenue function, determine the break-even point. And they do tell you at the end that let x represent the number of canoes, so that makes this thing balance out. So you're kind of knowing what you're looking for. Okay, so taking this apart, here's where we're going to break it down. It says write a cost function. How much does it cost to make each canoe? Well, it's $20, and that's it, right? So for that one, let's say write an equation. Well, y is equal to 20x. Sorry, we're doing functions here. Hang on, let me change that. Instead of y equals, because it's a function, we got to do that as c of x. So c of x would equal 20x. Okay, for the b part. Oh wait, forgot about the fixed cost back here, right? So that's your electricity, your rent, your mortgage, your all insurance, all those other things you've got to do. That's the stuff you're going to have every month. Plus, it's $20 cost every canoe. So your cost is $20 per canoe, plus $18,000 you've got to do regardless of whether you're selling canoes or not. All right, your revenue. We go R of X. Well, it's $80 per canoe, so 80x. No, they're not doing, for this one, they're not doing it's not profit per canoe, this is just the revenue. How much money are we getting back? Now, we'll get to the break-even point here in a second. So we've got a cost function, we've got the revenue function, it says determine the break-even point. From there, then I think you just take it so that your cost is equal to your revenue, right? Okay, so let's get rid of the 20x. Take the 18,000 divided by 60. That's going to be 300. Right. Drop out the zeros. It's 1,800 divided by 60. Yeah, be 300. Okay, so break-even point. Gotta sell 300 canoes to break even. Now, I think they did ask how much money would you get for that part, so then you could just do the 80 times the 300. So your revenue, or your cost amount in that case, would be just plugging the x equals 300 back in up here. That would be, what, 24,000? So they might ask for that. For me, I'm looking for the amount of canoes you got to have. They may ask for both, just in case they do. Either the revenue, since it's equal, the revenue or the cost, both of them should be 24,000.